This video is a continuation of Pythagoras' theorem in trigonometry. This video is looking at the more real-life situation trigonometry questions that might appear on the Leaving Certificate exam. So sometimes the examiner can give us a real-life situation in which requires the use of Pythagoras. You can also be asked to list assumptions you have made. Don't let this confuse you. We're going to go through questions like this, and question 2.6 will hopefully help help you understand what's going on. So it says here, a kite is held by a string 13 meters long. When blown in the wind, it is 9 meters above the ground, as shown in the diagram. How far is point A from B correct to the nearest meter? List any assumptions that you have made. So the assumptions, first of all, we look at this. So the first thing we have to do is we have to assume, I'm going to assume that the kite which is the length of the string, is at its longest. Which is 13 meters. So what we're assuming is that in this question, the distance from the kite, which is at the top of line A, down towards B is 13 meters. So we're assuming that the kite is out that 13 meters long. We also have that when blown in the wind, it is 9 meters above the ground, as shown in the diagram. So we're assuming that this length here is 9 meters. Now we're trying to figure out then how far point A is from B. So this, when we're in maths, when we don't know what something is, we use X. Now, as you can see here, we have a right-angled triangle here. When we see a right-angled triangle, the first thing we should always do is write down Pythagoras' theorem, which is c squared is equal to a squared plus b squared. The next thing I'm going to do is label the sides. So we have here that C is always the hypotenuse, which is always opposite the right angle. So in this question here, we're going to label 13 as C. Then I'm going to label X maybe as A and 9 as B. So then I'm just going to fill it into the formula. So we said that C is 13. So 13 squared is equal to A, which is X squared, plus B, which is 9 squared. So 13 squared is going to give us 169. That's going to equal to X squared, and then 9 squared is going to be 81. So I'm going to take 81 from both sides just to get the X squared by itself. So 169 take 81 is going to give us 88, and that's going to be equal to X squared. So then we need to get the X, so X is equal to the square root of 88. You're going to get X is equal to 9.38 meters. But if you read the question here, it says how far is point A from B correct to the nearest meter. So we need to make 9.38 correct to the nearest meter, which is X is equal to 9 meters. And that's that question done. So just to go back to list any assumptions that you've made, we're assuming that the kite length, which is the length of the string, is at its longest, which is 13 meters. So we're, for example, at B, the person is holding the kite at its longest. And then we've solved the distance between A and B. So that's question 2.6 finished. Question 2.7 is shown here. It says, show that Sutton is 14 kilometers further from Birmingham than Walsall is from Birmingham. So what we need to get is we need to get the distance from Walsall to Birmingham. And we also need to get the distance from Sutton to Birmingham. And what we should see is that the value we get up here is much greater than the value we get down here. And to be particular, it is 14 times greater. So I might do the first one in blue just to separate them out. So what we have here, I haven't even looked at the diagram yet, but now we can start looking at the diagram. So we have Walsall, which is here, and we need to get to Birmingham, which is down here. Now, so I'm going to focus solely on this triangle, which I'm going to highlight in green. And for this triangle, what we're looking for is we're looking for the distance from Walsall up here down to Birmingham down here. Now, in maths, when we're trying to find an unknown, we usually call it x. So I'm going to label this here as x. Now, again, of course, we're in the trigonometry Pythagoras theorem video, so we're going to be using Pythagoras' theorem. Some people ask, well, how do you know to use Pythagoras theorem for this question? We're going to be looking at later how you can decide and how you can pick to use Pythagoras theorem for this question. So don't worry about understanding why I'm using Pythagoras theorem at the moment, in terms of why aren't I using another trigonometry rule or SOHCAHTOA, or even the sine or cosine rule. That will all come in time when we're going through how to figure out which rule to use. For the moment, we just need to know how to use Pythagoras' theorem. So Pythagoras' theorem is c squared is equal to a squared plus b squared. We know that c squared is the hypotenuse. The hypotenuse is the longest side, and it's always the side opposite the right angle. So here we have the opposite, which is x. So we have x squared is going to be c. We're going to have 6 maybe as a and 8 as b. So this is going to become 6 squared plus 8 squared. So 6 squared is 36 and 8 squared is 64. We add them together, we're going to get 100. And then we figure out that x is equal to 10. So the distance from Walsall to Birmingham is 10 kilometers. So I just might highlight that maybe in yellow. We're going to come back to that at the end and see whether what they're saying is true. Now I'm going to rub out just what we've looked at on this triangle so far, because we need to use it now to figure out the next part. However, we do know that the distance from Walsall to Birmingham is 10 kilometers. We need to figure out then the distance from Sutton to Birmingham. So now we're looking at a different triangle. We're going to look at the triangle that I'm kind of highlighting here now. So again, in maths, the distance or the whatever we need, we usually label x, and we're trying to find the distance between Birmingham and Sutton, so this will be x here. So again, we have Pythagoras' theorem, which is c squared is equal to a squared plus b squared. C is the longest side, which is the hypotenuse, and that's always opposite the right angle triangle. So I can draw a little arrow in here. And in this case, C is going to be 26. So you can see that the triangle here looks a little bit different than any triangle we have looked at so far, and it's literally just because it's placed in a different way, so it's turned a little bit on its side. Then the other two sides, it doesn't matter. One can be A and the other can be B. It doesn't matter which way. Then we're going to get that 26 squared is equal to A squared, which is x squared, plus B squared, which is 10 squared. 26 squared will give us an answer of 676, which is equal to x squared plus 100. So then I'm going to take 100 from both sides so that we can have the x by itself, and we're going to get that 576 is equal to x squared. To get x by itself then, we're going to get the square root of both sides, and the square root of 576 will give us 24. So then the distance from Sutton to Birmingham is 24 kilometers. So I'm going to highlight that then as well, and then show that Sutton is 14 kilometers further from Birmingham than Walsall is from Birmingham. We've shown that because the distance from Walsall to Birmingham is 10, the distance from Sutton to Birmingham is 24, which is 14 kilometres more than Walsall to Birmingham. So that's that question complete. The final question in this video then is question 2.8, and that says the height of a wooden goalpost is 2.5 metres and the width is 7 metres. James wants to play a prank by nailing X bars on the goal as shown. What is the minimum total length of wood that James needs to make the prank a success, correct to the nearest metre? The first thing I'm going to do is I'm going to fill in all the information that I know, and I know that this up here is 7 metres and I know that this here is 2.5 metres. Now, I always like to draw my own diagrams to make it a little bit easier. And what we have here is we have two triangles. So the first triangle would be this one here, which I'm going to draw in blue on the diagram that they've given us. So I'm just drawing out this triangle. Now, we know that, well, if this side is 2.5, this side is also going to be 2.5. So the triangles that we have here, the two triangles, are the exact same. So if I draw this one in red, the two triangles now that I have are the exact same. So we need to find the length of the X bar. So we need to find the length that I'm going to highlight here in green. We need to find the length of both of these. So if I find the length of one side, I'll be able to find the length of the other side. So this here is a right angle triangle. And the reason why that is if you've ever seen a goalpost, it definitely is 90 degrees. And we know that this is 2.5 and this is 7. Now we're trying to find the length of one of the parts of the X. When we're trying to find something in maths, we usually label it X. So for this, we're using Pythagoras' theorem. So that is c squared is equal to a squared plus b squared. C is always the longest side, which is always the hypotenuse, which is opposite the right angle. So it's going to be X in this example, and then A and B can be any of the remaining ones. So we have here c squared is equal to 7 squared plus 2.5 squared. 7 squared is going to give us 49, so we'll get c squared is equal to 49 plus 2.5 squared, which is 6.25. So what we'll get then is c squared is equal to 49 plus 6.25, which is 55.25. We need c by itself, so we get square root of both sides, so the square root of 55.25. So c then is going to be equal to 7.433. So now that's the side of 1, so we need 2 planks. So we need to multiply 7.433 by 2. So when we do that, so 7.433 by 2, that will give us 14.866. So that's the length of kind of wood that we need to do this prank. But of course it says here, what is the minimum total length of wood that James needs to make the prank correct to the nearest meter? So correct to the nearest meter, the minimum length correct to the nearest meter is 15 meters. And hopefully that makes sense. So go through these questions and make sure you're comfortable with them. Try the questions that are up on the online learning platform, and then in our live class we will go through the answers, making sure you understand everything, and that Pythagoras' theorem is hopefully a nice easy question for you to answer if it comes up in an exam. This is then the end of this video, Trigonometry, Pythagoras' theorem, video 2.